Now, when you first bought your Commodore 64, you may have bought some programs to go with it. That's pre-written programs. But if you wanted to write your own programs to get the machine to do what you wanted to do, you'll have to learn a programming language. And the programming language we're going to be talking about during this videotape is BASIC. That's Commodore 64 BASIC. And before we start to learn the instructions of the BASIC language, we'll take a quick look at what's inside the machine so that you can understand the effect they're going to have. Now here's the screen that appears when you first turn your machine on. This first line tells us that our Commodore 64 is ready to use BASIC. On the second line, it tells us it's a 64K RAM system. And that means that there are something over 64,000 characters of memory in the system. These characters of memory are also called bytes. And the second half of the line tells us that we've nearly 39,000 bytes available for use in BASIC. The difference between the 64,000 and the 39,000 is the fact that there is already a program in this computer. That program is BASIC, and it consists of the instructions that will be used to understand the basic statements that we write. So what does a BASIC program look like? I've put a very short program into the computer, and then I've asked the computer to list all the instructions in that program. I've changed the printing to white simply so that it's easier for you to see it on your television set. And you'll see how to change the output yourselves to different colors as we go through this videotape. The 10, 15, 20, up to the number 40 are what are called line numbers, because each of these is one line in our BASIC program. And that's the first rule. Every line in our program must have a number. At the top, you see the word list, and that's just the instruction I typed in to make the computer list all the lines in the program. And the ready at the bottom tells me that the computer is ready to accept another instruction. Let's look a little more carefully at what's in these lines of BASIC. Now, words like input and print are part of the BASIC language. These are English words that have a special meaning when we use them in BASIC programs. OO, AA, and CC, that you can see I've used here, are words that I've invented for a special purpose in my program. And we'll see that there are rules about inventing words. You'll notice that all these line numbers are in ascending order. We start at 10 and we go up to 40. And this order of the line numbers is also the order in which those instructions will be obeyed when we start to run this program, to tell the computer to follow those instructions. Well, let's see what happens when we do that. We'll type run, R-U-N, and press the return key. It's come to the first instruction in our program, and although we'll go into the details of this one later, this instruction says, print out this message and wait for a number to be typed in. How many oranges? Let's say 5. This line has no function at all. I just put it in here to make this a little more readable for you with your television sets. So we come to the next one, number 20. Same sort of instruction, print a message, and then wait for a number to be typed in. Let's put 12 for that. Again, a line that does nothing, but I've put in to space these out for you, an instruction to print the total cost, and CC, total cost 304. So the run instruction has taken all these statements in my basic program and obeyed them one at a time. The program is finished and it says ready again. So that's the basic principle of writing a basic program. We enter a series of instructions into our computer, each one having a line number. When all those instructions are in the computer, we type run. And that tells our computer to execute those instructions, to obey them one at a time in the order of the line numbers. And as you can see, the result of those instructions was to print messages out onto the screen, to wait for us to type in numbers, and to print out an answer for us. Now let's look to see how we got those instructions into the computer. We need to look at the relationship between the keys on the keyboard, what goes into our program, and what appears on our screen. Now the main part of the keyboard is just like a typewriter. It's got letters on it, and numbers, and certain special graphics characters. Over on the left-hand side of the keyboard, you see 5 special keys which we'll be using. They're marked CTRL for control, run stop, shift lock, shift, and this one with a special symbol on, which is the Commodore symbol, and so we'll call that the Commodore key. Now over on the other side of the keyboard, you'll see some other special keys. At the top, 2 keys marked CLR Home and INST Del. And that stands for Clear Home and Insert Delete. And we'll be using those when we need to change and correct our program. Below them, the Restore key, and below that, the Return key, which we'll be using possibly more than almost any other key in our program, because we use that to indicate the end of each line and the end of each command. At the very bottom, you see another Shift key, same as on the left-hand side, and 2 keys with arrows on, and the word CRSR, which stands for cursor. And we'll use those to move up, down, left and right across our screen. We'll start by typing in a couple of very simple basic instructions. Let's start with a line number of 10. We'll put a space to make it a little clearer. We'll say print, P-R-I-N-T, and another space. Now the next character I want to use is the quotation mark, which you see above the 2. And in order to get one of these special characters above the numbers, I have to hold down the Shift key while I type. Instead of the number 2 appearing, I've got the quotation mark. Let's tell it to print something fairly simple, like hello. And because we started with the quotation mark, we must finish with 1, Shift, and the 2 key. Now to show my computer that's the end of that line, I press the Return key. And apparently nothing happens. Because I've used a line number, my Commodore 64 knows that that's not to be obeyed immediately, but it's going to be part of a program. It's got a line number at the front. Let's add another line. Let's make it line 20. We'll use print again, P-R-I-N. Right, I've made a spelling mistake. Now obviously you are going to make spelling mistakes as well. And that's why we have a key marked Del for delete. Because each time we press that, we rub out the character we just typed. I've rubbed out the E, I can now put a T in place. Let's put John and another quotation mark. Again, when we press return, nothing seems to have happened because that has been accepted as a line of BASIC and it's gone into our program. Our program should now consist of 2 lines, and we can check that by using a list command, telling the computer to list all the basic statements we've put in. L-I-S-T, and you'll notice that there is no line number at the beginning. We don't want this to be part of our program. We want this to be obeyed immediately. And as soon as we press return, the 2 lines in our program are listed. And we have the ready message, saying that our Commodore is ready to receive another instruction. Well, let's run that program. R-U-N, and we have to type run. We mustn't use the key that has got run printed on it. As soon as we press return, 2 print statements are executed. The first one says print hello, the second one says print John, and so the result is that we get hello John printed on the screen. The Commodore has finished what it's doing, and once more it's given us a message saying ready. So we can add a line into our program simply by typing it and making sure that we have a line number on the front. And that line will be stored away as part of our program. We can use a list command to give us a list of all the lines that are in our program at the moment. And then when we want to run our program, we simply type run and press the return key. And the statements that are in our program will be run. We've seen the delete key used to rub out the last character we typed. But often we want to make more complicated changes than this to our program. We need to take a line that we've put in and insert or delete characters in that line. We'll need to replace a complete line or insert a new line in the middle. Well, now we need to see how to do those things. We'll start by making some changes to the lines we've already got. And to do that, we're going to be using some of these special editing keys on the right-hand side of the keyboard. But because our screen is rather full at the moment, we'll start by clearing the screen. Here's the function that gives us clear. That's at the top of this key. Because it's at the top, we must use the Shift key in conjunction with this key. And as you see, that gives us a clear screen. Let's list the program. And now we're ready to change those lines. These 2 keys at the bottom, cursor up and down and cursor left and right, in conjunction with the Shift key, allow us to move that square flashing cursor around the screen. If we hold down Shift and press cursor up, you'll see it's moved up 1 line. Do it again and it's gone to line 20. If we use the cursor right key, you can see that it moves along that line. Let's change John to Joan. And we can do that very simply by positioning our cursor over the H and typing the letter A. You can see that the A has replaced the H and the flashing cursor has moved on 1 place. Now when we press the return key, that line 20, the changed line 20, has become part of our program. Let's move the cursor down 1 line so that we're on a blank line. We'll type list once more, and you see that line 20 has been changed. So we can use our cursor moving key to move to any line in our program that we've listed. We've got cursor right. With the Shift key we have cursor left. We have cursor down and cursor up. We can then change any character we like And when we press the return key with a cursor on that line, that new line replaces the old line. If we list that program again, you'll see that second change has been made. Let's clear the screen. Shift clear, list, and see how we insert a new character into the middle. Let's suppose that we want to say hello there. You may have noticed that the cursor moved very quickly then, because I kept my finger on the key, and it automatically continues to move. We can make more space in this line by using the insert function on this key. Because it's at the top of the key, we need to use the shift key at the same time. And each time we say shift insert, an extra space is inserted into the line. And now we can type whatever we want to in that space. T-H-E-R-E gives us hello there as our line 10 as soon as we press the return key. Let's move down, type list, and return, just to make sure that change has been made to line 10. And in the same way, we can use our cursor key to move up, to move right, and to delete characters by pressing the insert delete key without pressing the shift key. When I press return, that new version of line 10 has replaced the old version. I can list the program again, and you can see that the new line 10 has replaced the old line 10. So we can replace a line in our program either by typing it again from the beginning or using the listing of the old version of the line and using the cursor keys and the insert and delete keys to make changes to that line. If we wanted to remove a line completely, let's suppose we want to remove line 10, we can simply type its line number. If I just type 10 by itself and then press the return key, that's told my computer to forget line 10. Line 10 will no longer be in my program, and once more I can use list, which will show me that I only have line 20. There is no longer a line 10 in my program. So these are the basic editing skills that you'll need to put in your own programs. Typing in a new line, making sure it has a line number at the beginning, deleting a line by typing the line number and pressing return, and using the editing keys, the cursor up, down, left and right, and the insert and delete keys to make changes to existing lines. Now practice those skills when you've finished watching this videotape, because these are the basic skills that you will be using all the time when you're writing your own programs. Now, having seen how we can control the lines in our program, let's go back to that original program and have a look at the basic statements that were used there, because input, calculation, and printed output are the basis of most of our programs. We have 4 basic statements here, 2 input statements, which have the word input at the beginning, 1 print statement, starting with the word print, and a statement here which doesn't start with any special word, but which is called an assignment statement. Let's take each of these and see what effect they have. When we execute an input statement that looks like this, the word input followed by a quotation mark and some characters followed by another quotation mark, the first thing it does is print that message out for us. I've got a semicolon there and then OO. Now, OO is a word I've invented myself. It's a name I'm going to use to refer to a variable. I've got another one here called AA, and I've used a third one here called CC. So before we go any further in decoding these statements, we should describe just what variables are. Now, in order to work properly, our program needs two things. Firstly, it needs the instructions, and we've just been looking at some of those. But the other thing it needs is data, information to work on. This could be numbers that we're going to calculate with, or perhaps people's names and addresses that we'll print out or look at. And this data has to be stored in the machine's memory, in the same way that our statements in BASIC are stored. Now, to make life simpler for us, we don't use numbers of addresses. We use a name to identify each of our variables. And when we use a name, OO, AA, or any of the other variable names we'll be seeing later, the first time we use it, BASIC will say, there's a new name, I will allocate a piece of memory to that name. And then any number or name or string of characters that we put into that variable will be stored into that particular piece of memory, and we'll be able to use it later. Let's see how that works in this input statement. Having printed out the message, how many oranges, the input statement expects us to type something in at the keyboard. Now, OO is not a word that BASIC recognizes. It's not part of the BASIC language, like input or print. So when it finds OO, BASIC says, I've got a variable called OO. Whatever number is typed in as a result of this input statement will be put into a piece of memory, and that piece of memory will be called OO. And I'll be able to refer to OO later in my program and get access to the same piece of memory, and so the same number that was typed in. Similarly, this second input statement again prints a message and asks for another number to be typed in. This one's called AA, O for oranges, A for apples. Again, it's a name that BASIC doesn't recognize, so another piece of memory will be allocated. It'll be called AA, and the number that was typed in response to this input statement will be put into that part of memory. Now we come to line 30, and that says CC equals OO asterisk 20 plus AA asterisk 17. Now this is a calculation. The plus sign obviously indicates addition, and the asterisk is used by BASIC to indicate multiplication. When BASIC executes this statement, it says CC is yet another name that I don't recognize. It must be another new variable. Allocate some memory for CC, and then whatever the result of that calculation is, put the answer into the piece of memory I've called CC. The calculation is OO, that's the number we first typed in, multiplied by 20. AA, the second number we typed in, multiplied by 17, and add together the result of those two multiplications. The answer to that complete calculation will be another number, and that will be put into the piece of memory called CC. So down to the fourth statement, print, and we use print to display information on the screen. Print total cost. Now that's a constant value, that will always be the same. It has quotation marks around it, so the first thing this print statement will print will be this series of characters, TOTAL space COST colon space. A semicolon means, having printed this thing, print this immediately following it. Now, it's not going to print the two letters CC. This is our variable name that we used in this statement. So the number that's stored in the piece of memory with name CC will be printed. Let's run this program using some very simple numbers for our input and see that the effect is correct. Run and return. How many oranges? Let's just use one orange. Press the return key to say that's the end of the number. We'll move from that statement to that statement, print out how many apples, and wait for us to type in a number to go to the variable AA. Let's just use one apple as well. Press return. It does the calculation, and the answer of the calculation goes into the variable CC. 00 is 1. 1 times 20 is 20. AA is also 1. 1 times 17 is 17. 20 plus 17, 37. So after this statement, there will be a piece of storage whose name will be CC, and it will contain the number 37. So that when we come to this print statement, total cost and a colon will be printed, total cost and a colon, and then the number in the storage called CC, 37. It's now come to the end of the program. It's produced all the printed output that it's going to produce, and so we again have our message ready. Now what we've done is to make a copy of a slightly extended version of this program onto the soundtrack of the video cassette that you're watching now. And you can copy it into your own computer to experiment with it if you follow this procedure. You need to make a copy of that recording onto an ordinary audio cassette. Connect the headphone socket or the line-out socket from your video player onto the microphone socket or the line-in socket of an ordinary audio cassette recorder. If you play the videotape while recording onto an audio cassette, you will have a copy of the program on your audio cassette. You can then take that audio cassette and put it into your Commodore dataset machine, and then load the program in the same way that you can load any other program that you've bought or that you've saved yourself. What we're going to do now is to add a little color and a little format to our screen display. Now, in order to show you the colors clearly, we've had to get rid of the blue background to the screen and use instead a fairly light gray. Now, the statement that allows you to do this you'll find in your user manual, and you'll see it at the top of the screen. And as soon as I enter this statement, then the screen color will change, and we'll be able to look at some different text colors. This poke instruction is the one needed to set the background of the screen to light gray. If I press the return key, you can see a nice gray background on which we'll be able to display some colors. Let's start by listing the program. And this is the one that you've been using, experimenting with, if you copied it down from the videotape. What we're going to do is to make it print out this text in various colors. Here we have 4 input statements, which cause values to be printed, 4 print statements, and a 5th print statement. Now, the simplest way to get the Commodore 64 to print things in color is by using the color codes that are available on the keyboard. Let's clear this screen and see which keys we're going to use. On the front of the number keys, you see abbreviations for various colors. And we use the control key in conjunction with these keys to obtain the various effects. If I hold down the control key and press black, you'll see that my flashing cursor has changed to black. And any characters I type will be black. If I hold down the control key again and press white, my flashing cursor changes to white, and any subsequent characters I type will be white. Similarly with red, cyan, purple, and so on. Now, obviously, different color combinations will work better, some better than others. So we'll put a few of these colors into our program to show how you can make your basic statements print using these colors. What we'll do is to print character strings, that's between quotation marks. But those strings, instead of containing words or questions that we want to ask, will contain just those color codes that we saw typed a moment ago. Let's add a statement to the beginning of our program that does just that. The first line number we have in the program is 10. So I'm going to add a new line number 5. That's going to be a print statement, print quotation mark. But now, instead of an ordinary character, while holding down the control key, I'm pressing 8. That's got yellow written on the front. But we don't get yellow immediately on the screen. We get this rather strange reversed character. And we'll find that all these color codes and some of the other codes that we see, when we put them in a print statement like this, they don't appear as their color, they just appear as strange symbols. Let's put another quotation mark in and end the statement. Now, line 5 should tell the Commodore that whatever is printed afterwards should be printed in yellow. Well, let's clear the screen and run the program to check that it works. Shift clear to clear the screen and run to run it. As you can see, the very first piece of text to be printed out has been printed in yellow. The cursor is still flashing yellow, and whatever I type, because that's being printed back onto the screen, that also appears in the current color. So I go through the program, fill in all my numbers, all the output has come out in yellow. Even the word ready at the end of the program is yellow. Perhaps I should add another line to my program which would reset the color to white just before the program finished. I've made the change, and as we list the program, you see that line 60 says print, but what we're printing appears to be a reversed letter E, and that's the print code for change back to white text. Let's clear the screen and run this version of the program to make sure we switch back to white text as the program terminates. Clear the screen, run, 1, 2, 3, 4. As you can see, all the output from the program is yellow, but because of that line at the end, the ready and the flashing cursor are now both white. So we've only used yellow for the program's output. We've come back to white for our next command. And in fact, we can put as many different changes of color as we like into the program. And each time we put a new color code into a print statement, we'll see that the printed output after that point changes color. I've added some new color codes to the program, and as we list it, you'll see where they are. Notice that in the first case, I had a print statement by itself to print the color code. But I can also put the color code in the middle of an input statement, just in with the other characters. Because there's a quotation mark in front of it, the Commodore knows that that's to be a color code change within the statement. So I have 3 input statements here, each with their own color code. I reset the color at this point, and at this point, and at this point. And you see each of the different color codes has a different reversed symbol. Let's clear the screen and run it, and you'll see the effect. Shift clear, run. Yellow, red, white, purple, blue, green, and finally back to white again. So it's very simple to get colored text appearing on our screen. All we need to do is print one of the color control codes. Now I've made a couple more changes to the program. As I run it, see if you can spot what they are. 1, 2, 3, 4. The difference is that 3 of these lines, this one, and this one, have come out not as colored text on a gray background, but as gray text on a colored background. We've reversed the way the printing is done. We've achieved that through 2 other keys on the keyboard. Under the 9 key, you can see reverse on, and under the 0 key, reverse off. So that white line, how many apples, has been printed under the control of white text, but reverse on. The blue line is blue text with reverse on, and the green line is green text with reverse on. Notice the difference between the green one and the blue ones. If we list the program, you'll be able to see what I mean. The change is here in line 20, where as well as a color control character, we've got this reverse R, which means switch on reverse printing. So the rest of this text is printed in reverse. Similarly here in line 30, we have another reverse code. And here in line 55, we have a reverse code at the beginning, before the words total cost. But after total cost, we have this code, which is a reverse off code. So total cost is printed in reverse, but when we print CC, we will print it with reverse off. So that's printed normally. Notice that although the color code will last for many lines, the reverse code only lasts for a single line. When our printing moves to the beginning of the next line, the reverse code is cancelled. Now, as well as color codes and reverse on and reverse off within our strings that we print, we can also control the layout of what's being printed, because we can include the home, clear, and cursor up, down, left, and right codes within the things we're printing. I've changed the program again to give you an example of this. Now, when we run it, the very first thing it does is to clear the screen. And as we feed in the 4 numbers, you'll see the other changes. I've put a bigger gap in here, and I've made sure that the total cost is moved across from the left-hand side by a few spaces. If we look at the listing of the program, we'll see how I achieved that. Here I have line 3, and I'm printing what looks like a reversed heart symbol. And that's what you get if you put a clear inside quotation marks as part of a print. So the very first thing that happens is that the whole screen is cleared. Down in line 27, these reversed Qs are in fact cursor down commands within quotation marks. So as soon as I've printed these 4 lines, I'll move down several lines before I print the next part of my output. And then finally, in line 55, what look like closing brackets, reversed, are in fact cursor right instructions, again between quotation marks. And that makes sure that total cost isn't printed at the very left-hand side of the screen, but is indented a small amount. Now, we've recorded this program in the same way as the other one onto the soundtrack of the video cassette. So if you want, you can download this into your own computer and experiment with the different color and cursor control codes. And after this break, when we come back, we'll look at some more complicated logic in our program, making it loop around, repeat, and, well, you'll see what happens. The first program we looked at was a straight line program. We started executing at the first statement and carried on to the last one, and then stopped. Now, of course, most programs are much more complicated than that. So we're going to look at a different program which has more logic in it, which can execute the same statements over and over again. And incidentally, it also has more complicated data handling within the program. So we've got quite a bit to look at in this program. Let's start by seeing how the program works when it's run. It's the same sort of program to do with calculating prices. But this time we haven't got a fixed number of things. We can have as many different things as we like. Well, let's choose a small number to start with. Let's try 3. And for each of them, we're going to have to specify what it is and how much it costs. Well, let's start with cats. That's the name, then a comma, and the price. And let's say the price is 12. Now, because we said there were going to be 3 different things, we're asked again, name and price. Let's put dogs, and 15 for that. And let's put fish, and 18. So that's the first piece of information that we're going to have to put into our program. We've said there are 3 different things, and then for each of those things, we've been asked a name and a price. And our program has to remember those 6 pieces of information, the 3 names and the 3 prices. Let's press return for the final price, and we're asked another question. And notice that this question includes one of the words we typed in. We typed in cats, and cats is coming back to us in the question. Let's say 5 cats. How many dogs? 3 dogs. How many fish? 18 fish, let's say. 429 is the total price. So the arithmetic in this program isn't very complicated. And now we're asked another question. Do we want to do any more? And if we answer Y for yes, and press return, we go back to the beginning. How many cats? 2, 3, 1, for example. Again, it works out the total price and comes back to us again saying, do we want to do some more? This time perhaps we'll say N for no and press return, and the program finishes. So the logic of the program in this case is quite a bit more complicated. Let's look at it step by step to see how it did the job. I'm using a slightly different version of the list command here because I only want to start by looking at lines 10 to 30, not the whole program. So let's look at these 3 lines. Line 10, print a clear screen. So that means the program starts with an empty screen. Line 20, an input statement. How many different things? I've got a variable here called n, so whatever number I type in as a result of this question will be put into the variable n. So that tells me how many different things I'm considering. Now this is a new statement, dim, and it stands for dimension. I'm setting up 2 more variables called names dollar and prices. There's something rather special about this one because it's got a dollar at the end. Instead of just names, it's names dollar. And that means it's not going to hold numbers like the variables we've used so far, but a string of characters, because I'm going to use this variable to hold the name of the thing I'm buying. Cats, dogs, whatever I like. Prices is just a normal number. So into the variable prices, I can put any value I like. Now, what does this n in parentheses mean after each of these variable names? What it means is that instead of just one variable called prices, I want quite a lot of them. Suppose the value of n was 3. I'd typed in 3 in answer to this question. This tells BASIC that I want to set up a table of prices. I'm going to use prices number 1, prices number 2, and prices number 3, because I have 3 different things I want to record the prices of. Similarly here, names dollar n. N is 3, and I'm going to use names dollar 1, names dollar 2, and names dollar 3 for the 3 different names I'm going to type in. So for the first purchase thing I type in, its name might be cats and its price might be 20. So the value of the variable names dollar 1 will be cats, and prices 1 will be 20. If the second thing we entered was dogs, whose price perhaps was 15, then names dollar number 2 would be dogs, prices 2 would be 15. Similarly, we'd have a value for names dollar number 3 and prices number 3. If we'd put in a value of 100 for n, then we'd have room for 100 different names and 100 different prices. So those first 3 lines have cleared the screen. They found out how many different things we're going to be dealing with and have set up little tables in our program to hold their names and their prices. Let's look at the next section of the program. From 40 to 70, this part of the program deals with getting the names and the prices for each of the things we're dealing with. Print name, comma, price. That just prints out that one line to remind us what information we're supposed to be typing in. Now the input statement we've seen before, let's look at these 2 statements that are around it. For, next. Now these two statements together make a loop. The effect of them is that the statement in between, in this case the input statement, instead of just being executed once as our program passes through it, is going to be executed several times. How many times? Well, that depends on this for statement. For m equals 1 to n. Now n, we know what that is. That's the number of different items we're interested in. That's the value we typed in first. This for statement and the next statement that go with it, m, says start m at 1 and execute that statement. When you've finished executing that statement, go round again and make m2 and execute that statement. And go round again and round again and round again, increasing m by 1 every time until finally we've executed this input statement with m having the same value as n. So if we type the value 3 for n, then this input statement in line 60 would be executed 3 times. One time with m being equal to 1, and then again with m being equal to 2, and finally once more with m being equal to 3. Now you might say, what's the use of executing the same statement 3 times? Well, let's have a look at it. Input, names dollar, and prices. We're taking in a name of something we're buying and its price. But instead of saying 1, 2, 3 to say which name we mean, we've used a variable, m, this variable. So the first time we execute this statement, m will be 1. So we'll get names dollar number 1 and prices number 1, the first name and its price. As we go round again, m will be 2, and we'll input names dollar number 2, prices number 2, the second name and the second price. And as we go round once more, we'll get the third name and the third price. So this little loop, this for next loop, will execute this input statement enough times for us to fill in all the names and all the prices. Let's move on and look at the next bit of the program. We start here with a print statement to clear the screen, and we've got another of these 4 next loops. This time there are 2 statements between for and next. Let's see what they do. The print statement says print how many, and then it uses a variable, names dollar m. We're using m in this for statement, so the first time m will be 1. So that means names dollar number 1. That's the first name we typed in. So the result of this print statement is how many cats, if cats happen to be the first name we typed in. If fish was the first name we typed in, we'd get print how many fish. Now after the print statement, we have an input statement, because we want to enter how many of those things we bought. When m is 1, we've just printed out the first one of our names. This is another table, quantity, and so the number we type in response to the input will go into the first item in the table, quantity. Second time around, we'd print out the second name, we type in another number, it will go into the second item in this table. So as we go round and round this, once for each different thing we're considering, we'll build up another table of the quantity of each that we bought. Here's the part of the program that calculates the total cost. We're going to use a variable called cost to keep the running total in. We start by making it 0. And then for each of the different things that we bought, Here's our for next loop. We take its quantity, multiply it by its price, add to the cost we've got so far, and that becomes the new cost. So cost is 0 to begin with. We multiply the first quantity by the first price, add that to 0, that gives us the cost so far. M becomes 2, the second quantity is multiplied by the second price, that's added to the cost so far, and that becomes the new cost. When we bean that loop all the way up to n, then cost contains the total cost for all our different things, and we can print it. Print the total price and our variable cost. And here at the very end of our program are two statements that control whether we do the calculation again with a different set of numbers or whether the program finishes. We ask the question, more? Do we want to do another set of calculations? It's an input statement, but this variable here, ANS dollar, isn't a number of the sort we've used before, but another character string variable. And we're going to put a Y in it, meaning yes, or an N, meaning no. Because line 210 is another new sort of statement, an if statement. Very powerful statement, this, because it allows the program to make a decision. If answer dollar is equal to Y, if we typed in a Y as a result of this input statement, that means we want to do some more calculation. Go back to line 100 and carry on. If the answer wasn't Y, if it was anything else, then we don't go back to line 100, we just continue. And as that's the last line in the program simply stops. So you'll very often put a couple of statements like this into your programs. Ask the user, does he want to do any more? Let him type, for example, Y for yes, N for no. If the answer is yes, then go back to another part of the program and carry on again. If the answer is not yes, finish. We've only had a chance to look at a small number of the statements available in Commodore Basic during this videotape, but I hope they'll get you off to a good start with your programming. And that last program we looked at is recorded onto the videotape following this, and as with the others, you can copy it into your own computer. In the second tape in this series, we'll take a look at some graphics and some sounds, and look at the Commodore 64 perhaps a little more as a games machine.